Hello, everyone, and thank you for coming today. First of all, I'm actually representing Bin Yang and Jackie Heng from my team. They're the PTL and the TOC member of the O-RAN software community. Couldn't travel here because they're in China, so I'm basically representing them. I'm going to talk about the O-RAN software community infrastructure project, pretty much giving you more of the history, why it was created, what was achieved, all the way into the G release that it's currently worked and going to be released soon. So first of all, a little bit of about the history. So we started this project with the A release, the first release of the O-RAN software community. Wind River is a very key contributor to open source, and basically the whole idea was to create a cross-community collaboration and to reuse stuff rather than reinvent the wheel. So the focus of the project is basically creating a high-performance cloud infrastructure, low latency and scalable to address the needs that you need for workload deployment such as VDU, for example. Okay, this is based on the Sterling X project that it's really focused on solving those technical problems for more broader, so meaning a far edge and edge type of deployment. And the focus of the infrastructure project in O-RAN software community is to basically take this and extend it, okay, to support specifically stuff that it's related to O-RAN. This project works by hand with Workgroup 6 in the O-RAN Alliance, so basically taking the specification that is defined in Workgroup 6 from an infrastructure perspective and basically providing a complete open source solution that is implementing the specification. The focus basically in the G release and other releases, so as you heard, the start of O-RAN software community, it was kind of more each project worked on their own, and then as the releases started to evolve, more integration between different projects. So basically now we're at the point that we're focusing on an end-to-end integration. So basically, the infrastructure project used to run the different workload and testing an end-to-end side. If we're looking right now, specifically features that exist in the project, and those are just like the high level. But first of all, starting with implementation of specific parts to the O-RAN standard. The IMS, for example, the DMS, the O2 interface. Okay, those are more O-RAN specific versus, let's say, more open source wide far edge type of project like a Sterling X. Okay, so we're taking Sterling X basically, and inside the O-RAN software community infrastructure project, you're going to see the link to Sterling X and then all the additions to implement those interfaces. Implementing time synchronization. There was a mention about time synchronization on the open air interface project. We basically implement LLS C3 and LLS C1 here, okay, in the project, basically the whole configuration and everything. Those are, by the way, this exact same configuration and same open source and everything that it's today used in commercial deployment at scale. So you probably heard about Verizon being the first service provider that deployed 5G NR in fully disaggregated way. It's basically using Wind River Cloud Platform, which is the commercial version of Sterling X. Okay, when I say commercial version, it's a one-to-one match to the open source code. We just pretty much harden it and provide it with a complete lifecycle support. Okay, but we're talking about basically deployment that exceeds today tens of thousands of sites. So we take the learning also from those deployments and bring them into this open source project. And then basically the different types of, let's say, configuration. So a geographically distributed cloud, and then a configuration go from a single server. Okay, this is what we call the all-in-one simplex. Okay, where basically this project consumes 2 physical cores. So the whole platform overhead of a combined control plane, worker and storage, it's 2 physical cores, and the rest of the cores are used by the application. So to put it in context, today in commercial deployment, you have a 64 receive, 64 transmit, C-band massive MIMO video runs on a single server with 32 cores. Okay, and those are, if you're going to New York City, for example, you connect on Verizon 5G network on C-band, this is what you're connecting to, basically. Performance, time synchronization, it's actually one of the, let's say, more challenging things when it comes to the cloud solution. So this is just an example of the scheme and the performance characteristics of this particular open source implementation with the LLS C3 time synchronization use case. You can see the performance here. It's measured in nanosecond, and it's measured of the clock drift, basically. Scalability, again, I mentioned 4 types of configuration. So simplex, which is a single node that was listed. Duplex, it's 2 nodes with redundancy of the control plane and the storage. You can basically deploy the worker as just treated as 2 workers or as an active standby, active type of workload. It's really and then basically from there, growing dynamically, the cluster can grow basically up to 200 worker nodes within one cluster. And then with the geographically distributed cloud support that it's part of this project, you can have up to 1,000 clusters per one central region deployment. So basically, you can create a very large configuration like this. And the key important, it's growing dynamically. Okay, so you don't need to reinstall or restart the service. You basically just add more hardware to it, and the site continues to grow. Now, those are very critical, important, let's say, things that need to be supported in this type of network, because you're putting a site at the far edge that will run today your VDU, but then in the future, it may run multiple band. For example, it may run other workloads. Okay, so basically, for example, a UPF local breakout, and then from there, you're going to put some kinds of a MEC workload. Okay, and if you look at the agenda for tomorrow, there is all kinds of sessions in the metaverse and talking about the importance of low latency, the whole URLLC type of use cases. So if we're looking from a deployment perspective, we're basically, and again, this is all in the OSC infrastructure project. All this code, everything, it's working. Okay, you can take, there is an ISO image. You can build it, of course, from source code, but you can take an ISO image, install it, and deploy it. Okay, a complete distributed cloud where from a central region, basically, you deploy the central region. It supports full zero-touch provisioning and automation, deploying all the different sub-clouds. And again, today in commercial, we deploy this with thousands of basically sub-clouds. Okay, but in OSC, we of course support it. We test it in a smaller scale. If we're looking at the G release, specifically what's coming up in the G release, okay, it's first of all multi-OS support. So in the past, it was based on CentOS and transitioning into Debian. Okay, so basically transitioning into Debian 11 as then another OS that supported alongside with the CentOS. This is also basically, as you know, with the transition in the CentOS community to provide another option. Spec compliance, so evolving the specification, especially around the O2 interface, the IMS and DMS part. Integration with SMO, so basically, as I mentioned, with the SMO projects inside the O-RAN software community, focusing more, like I said, on an overall end-to-end integration. We invested a lot on the automation side, so AT&T originally contributed some code around the automation test framework, basically taking this code and getting the entire, what you call O-Cloud or INF project, tested through this test automation. So basically the build and test done through this automation. With the really vision, it's to get to a point where all the projects can use the same type of framework, so you can literally build everything and test this through one automated framework. And then I mentioned the integration, for example, so currently many of you may be familiar with the Intel FlexRun. So as part of the project, basically, we build Intel FlexRun from source code and run it on this infrastructure, only fully automated. Okay, so again, focusing on out-of-the-box experience with the intention to go to a more complete VDU down the road than just an Intel FlexRun. And then community labs, supporting different community lab, plugfests that are conducting using basically this O-RAN SC INF Project. 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 O-RAN S I will just conclude it by basically there was also data, this slide kind of provided in different format earlier, and really we call for more to participate in this project, in other projects. We're talking about a lot of open, and about ecosystem, and creating more options. We can only do it if we come together as a community. Thank you very much.
Thanks, Gil, for sharing.